morning, students. Welcome to Sri Chaitanya virtual classroom. Yesterday, we discussed what is the intensity of electric field due to a charged rod at a point along its length or on its axis and at a point on the equatorial line, right? Those two are important for NEET and JEE point of view. We recall that formula. Charged rod. If this is the rod of length L, this is center, this is of length L. If I take a point here at a distance R, from this end, intensity at this point, as I gave the charge on this is Q, positive charge. So outward P, intensity on axis, you can say here. And we discussed another point. Here is the point. Let it is P1. This is called equatorial line. The line which is perpendicular to the axis and passing through the center. At this point, what is the intensity along this line? We got that intensity in this direction, total intensity. Let that intensity is E2. So on axis, intensity, what formula we got? 1 by 4 pi epsilon naught Q by R into R plus L. This is the formula we got yesterday. At this point, on the axial line, here on the equatorial line, what is the intensity? 1 by 4 pi epsilon naught Q by LR sin alpha plus sin beta is one formula where angle made by this end is alpha, angle made by line joining this end is beta. Then this is 1 by 4 pi epsilon naught Q by LR sin alpha plus sin beta. In the last end steps, this R missed yesterday. Again, we rectified it. We corrected it. Q by LR sin alpha plus sin beta. If you simplify this, we got this formula 1 by 4 pi epsilon naught Q by R 2 by root over, this is our distance from here to here, R, root over 4R square plus L square. See, depending upon the situation, if angles are given, this alpha and beta are given to you, we use this formula. If in the problem, they give R, L, distance and length of the rod and the charge is given to you. If you are asked to find the intensity at a point on the along the equatorial line, we use this formula, right? These two we discussed in yesterday's class. Well, today, what is the intensity of electric field due to a charged ring? It is also one of the important concepts for NEET and JEE, not for PU. Charged ring, right? So we have a ring. This is a ring of radius capital and some charge is given to this ring. Let charge given to this ring is Q, positive charge Q in our assumption. The question asked is, along the axis of the ring, this is the axis of the ring. If this is a ring, then axis, a line passing through the center perpendicular to its plane, axis of the ring. On the axis, here I am considering a point P. A point P. Which is at a distance X from the center O of the ring. This point P is at a distance X, right? You are asked to find what is the intensity at this point P due to this charged ring. We know the procedure. This is also a extended charged body, not a point charge. So what we do, we take a small element on. Due to that element, what is the field here? Then we sum up field due to all the elements. Follow the procedure, right? Given that Q is the charge, total charge, R is the radius of the ring, X is the point, distance of point P from center O on the axis, right? At that X, we need to find intensity. Same procedure. Divide this ring into small elements. For that, first you need to know what is the small charge per unit length, we can say. Sometimes in the problem, if they give ring of radius R, if you take charge per unit, here what you can say, charge per unit circumference. See, if I give the charge to this ring, that charge completely resides on the ring. So this is the circumference, whatever the charge given totally resides on this. So what is the charge per unit circumference? Generally, sometimes it is taken as rho. Or circumference, you said lambda also you can write. You can write like this. Q by, what is the circumference? 2 pi r. Q by 2 pi r. 2 pi capital R, where capital R is the radius of the ring, right? This is charge per unit circumference. Well, let's divide this ring into small elements. Next step, charge per unit circumference taken. Then divide this ring into small elements. Take one such element here. See, this is a ring of some well, here I am taking a small element here, this part. Let charge for the small element is dq for the small element. Symmetrically, exactly here, I am taking same type of small element. Here also charge is dq. See, if I want to get q, if I add all those dqs, I'll get q, right? dq is the charge on small element on the length. If I add all those dqs, I get q. So I divided into small element. I took one small element here. Due to this small element, what is the field at this point? Right? See, from the small element, to find the field, I need distance from this small element to this point. From this small element to this point P, the distance is what? From the diagram, what you can write? This is X, this is R. It seems like a triangle. This and take that. Here, angle is theta. If this is X, this is R, this is adjacent side, this is opposite side, then this is what? Root over R square plus X square. Is this clear? If this is X, this is R, this is root over R square plus X square. Now it is just like here you have a point charge dq. From this, due to this point charge, at this point P, what is the intensity? We know intensity is in what direction? It is along the line. So the intensity direction is like this. Along this line. This is intensity. Let dE is the intensity due to this small charge. Right? In the same way, due to this small charge, symmetrically opposite. This is the distance. Is it not same as this? Because symmetrically opposite from here to here, this is the distance. So from here to here also, the distance is same. R square plus X square. Okay. Due to the small element, what is the direction of intensity? So due to the small element, it is along this line. This is D, right? Then along this axis, what is the intensity remains? Come on. This is not along the axis. This DE is not along the axis. Even this DE is not along the axis. Means its component comes along the axis. Divide these into two components. See this vertical component and this is horizontal component, or this is the component along the axis. This is the component perpendicular to the axis. Come on. If here angle is theta, here also angle theta. If this angle is theta, this angle is theta. If this angle is theta, this angle is also theta. because this is a straight line and this line. If it makes angle theta here, it makes an angle theta. Right? Come on. Now, what is the component of this DE along the axis? DE cos theta. Along the axis, that is DE cos theta. Perpendicular to the axis, DE sin theta. Right? DE sin theta. In the same way, for this, along the axis, DE cos theta, perpendicular to the axis, DE sin theta. Now, if you observe the diagram, this DE component along the axis, DE cos theta, its component perpendicular to the axis, DE sin theta. Its component along the axis, DE cos theta, its component perpendicular to the axis, DE sin theta. Observe these DE sin theta components. They are exactly opposite to each other. They cancel out. So, along the axis, what are the components present? All cos theta components. So, what is the component of actual DE along the axis? DE cos theta. Right? So, from the diagram, DE sin theta components cancel because they are equal and opposite. For every two symmetrical elements, they cancel out. DE cos theta components adds where? Along axis. Along axis. Right? So DE sin theta components cancel out. DE cos theta components add up along the axis. Now, what is the total field at P? E. Add up means integral. Which components? DE cos theta component. Right? Then what is DE? What is DE? First we write down. What is DE? Here only we substitute. E is equal to integral. DE means 1 by 4 pi epsilon naught. DE is the field due to discharge. dq by, this is the distance, root over 1 by 4 pi epsilon naught dq by root over r square plus x square whole square. I get r square plus x square. Is the point clear? This is the distance. There we take distance square. So if I take square of this, I get r square plus x square or root whole square. I get r square plus x square into cos theta. From the diagram, what is cos theta? From the diagram, what is cos theta? This is adjacent side. This is opposite side. This is hypotenuse. Then cos theta is equal to x by root over r square plus x square. X by r square plus x square to the power of half. Root over, I can write to the power half. Right? Is this point clear? dE means 1 by 4 pi epsilon naught dq by this distance square. R square plus x square. Root and square cancel out. Cos theta is adjacent side by hypotenuse. X by root over r square plus x square. Root. Root means half. Clear? Then E is equal to constants 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, x by r square plus x square whole power 1. This is r square plus x square whole power half. What comes? R square plus x square whole power 1 plus half, 3 by 2. So now what remains? Integral dq. This is remained, right? So constants 1 by 4 pi epsilon naught taken out. X, this distance won't change, constant, and this r won't change. So here 1, here power half, 1 plus half, 3 by 2. So under integration, what remains? dq. Okay. Next. 1 by 4 pi epsilon naught x by r square plus x square whole power 3 by 2. Integral of dq. See this diagram? If we add all those dq's, what we get? We get total charge. dq is the small part of the charge. Integral dq means what? Add all those dq's. If we add all those dq's, what we get? Q. So integral of dq is equal to q. Right? So 1 by 4 pi epsilon naught qx by r square plus x square. So the required result is 1 by 4 pi epsilon naught qx by r square plus x square whole power 3 by 2. This is the intensity at a point along the axis due to this ring. Clear? Come on, note down or take a screenshot right now. Is this half visible to you? This is r square plus x square whole power half. Whole power half here. Okay. Special cases of this. This is the intensity at this point at a distance x from the center. Sometimes they ask at center of ring, at the center of ring, what is the intensity? At the center of the ring, O, what is the intensity? Whenever you take the point at the center, so we are choosing this point at the center, means x is equal to what? X is 0 because x is the distance from the center to this point. Whenever you take this point at the center, this x is equal to 0. Remember, when at the center they ask in the formula, take x is equal to 0. See there, E is equal to 1 by 4 pi epsilon naught qx by r square plus x square whole power 3 by 2 is the formula there. Once this x is equal to 0, what happens? 1 by 4 pi epsilon naught q into 0 by r square plus 0 square whole power 3 by 2. 0, 3 by 2. Q into 0, 0. So E at center, 0. E at the center is 0. Second, when that x is much greater than r, that point x is much greater than r. Compare with this r, if this distance x is much greater, if this is only 1 centimeter and this is 100 centimeter, like that. Once x is much greater than r square plus x square is almost equal to x square. If you take r square plus x square whole power 3 by 2, x square whole power 3 by 2, 2 get cancelled. This is equal to x cube. Right? Then what do you get? E at x, at a distance x, 1 by 4 pi epsilon naught q x by x cube. So 1 by 4 pi epsilon naught q by x square. See, this formula is familiar to you. This is the formula due to intensity of electric field due to a point charge. See, whenever you take distance much more, this ring appears very small compared to the distance. So ring behave like a point charge. Whenever you get in theory questions, you can directly answer this. You just compare the values of x and r. If x value is much greater compared with r, immediately what idea should come to your mind? Ring is very small compared with the distance. So ring behaves like a point charge. So we get 1 by 4 pi epsilon naught q by x square. Right? Next. Next, where that E is maximum. See, if this is the ring, from the center, you can move this direction or this direction. As we are moving away from this center, this point, this point, this point, this point, like that, where that that E is maximum. Remember, to get E to be maximum, dE by dx should be 0. Differentiation of this. This is E. dE by dx. If you differentiate this, it equal to 0. So no need of that differentiation at all. We get, after this differentiation, we get E is maximum when x is equal to r by root 2. You remember this. Very important point. At x is equal to r by root 2, E is equal to E maximum. That means if this is the radius on either side, at x is equal to r by root 2, if this is the point, that if this is the axis extended at a distance r by root 2, even here also, x is equal to r by root 2 from the center, here E is maximum. Here E is maximum. That means what? As we come from the center, E goes on increases. Here it becomes maximum. Again it decreases. Here E is in this direction. Here E is in this direction. If you take that one as positive, this one is negative, right? Due to the ring on the left, this is the direction because this is a positive charge, I said. Positive charge is there on the ring. Here it is in that direction. In one entrance, they asked, what is the graph? Change of intensity with distance. By taking E on y-axis and distance from the center on x-axis, distance from the center to the point on x-axis, and E on y-axis, they ask how the graph is going to be for the ring. Now from this it is clear. As we go from the center in that along the axis, here it is becoming maximum. At what distance? R by root 2. Somewhere it is becoming maximum. Means it is increasing and becoming maximum. Then after what happens? It decreases. It comes like this graph. Where this maximum is? That is maximum where? At R by root 2. That is maximum. On this side, towards left, if what I told you, on that side this is positive vectors. If you consider vector notation, this vector is in this direction, means negative. So on negative side it comes like this. Here, R by root 2. Negative side, E max. So this graph is important. Even if you want what is the value of E maximum, in this formula, you substitute that R by root 2 in place of X, you get the value. Take it as homework. Do it. Substitute in place of X, R by root 2, you will get E maximum in case of the ring. In theory questions, you get two types of questions on this. Graph. At the center of the ring, what is intensity? Remember, at the center of the ring, intensity is 0 at the center, right? Come on, note down or take a screenshot. Okay, students, already I told you this question is for NEET and JEE entrance point of view. For PU, no need of derivation. Okay, only remember the formula. Just formula whenever it comes in problems, formulas and their special cases. It is purely entrance question. Purely entrance question. Right? There is a question in level 2. They gave the question like this. This is a ring. It is divided into 4 parts. Like this. And given that, what is the relation of intensity due to this part AB and intensity due to remaining part ADCB at the center? Intensity due to this part AB and intensity due to this remaining part ADCB. What is the relation? They asked. We know the total intensity at the center should be 0. Means intensity due to AB plus intensity due to remaining part ADCB. Can I write? Intensity due to AB plus intensity due to ADCB must be equal to 0. Then you can write EAB in vector form because intensity is a vector minus of EADCB. In level 2 problems, it is in level 1, I think, theory bits, but it is asked in entrance. There is a question, right? This is the ring, and due to this part AB, EAB is the intensity. They asked what is the intensity due to remaining part ADCB. This is negative of this because total intensity due to a ring at the center is 0. That we know. 0. So like that they design the questions on this. Next. Intensity of electric field due to charged disk, uniformly charged disk. All the objects I am discussing here are uniformly charged disks. See, there is a disk. This is a disk. Due to this disk, this is the center. Radius is R. From the disk, at a point on its axis, at a distance x, here, what is the intensity? Just I am giving you formula, derivation not necessary. Entrance point of view, formula is required. Sigma by 2 epsilon naught 1 minus x by root over r square plus x square. Remember this one. E is equal to sigma by 2 epsilon naught 1 minus x by root over r square plus x square, where sigma, surface charge density. Surface charge density. They provide it, this value. Means what? Total charge by area. Total charge by area. Q by pi r square. Important formula. Okay. This is also purely entrance point. For JEE needs entrance point of view, important these are. Students, again Sunday we have exam. So for that exam, again from Coulomb's law to intensity, up to motion of a charged particle in the electric field, up to there. Again, tomorrow I'll tell you clearly. See, you feel that this is a regular class. You take down the notes. and you write down what are the important points we are giving you. Based on that, you try to solve your exercise. If you don't have books, you get pics from your friends. Otherwise, we try to provide you that scanned copy of problems. We are trying to give the problems in the paper which are related to the discussed topic only. You can answer the paper when and only when you are following us and you are making your notes clearly. Okay. I hope that you are doing well and have a good day.